Good morning, everybody. Hold on. There's my microphone. Good morning, everybody, to this Wednesday where we are continuing into part 2 of the course. Let's just see here where we're at. As always, can someone just confirm in the chat that they can see and hear me, and then we can get going. All right. Thank you. Good. Now, chapter 4 is for you to read if you're interested in sort of the evolution of number systems in a very basic way. It's just there because I thought, oh, maybe it'll be interesting to see where did these things start, how did they keep track of numbers originally. It's just like a couple of pages. Read it if you're interested. Don't if you're not interested. Totally up to you. You're not gonna miss out. It's just for interest's sake. So our next chapter is really chapter 5. Now, what we're going to do, and I'm going to try and repeat this periodically, we are ultimately interested in the way we write numbers, the way we work with numbers, our decimal system. Yes. But the problem is, and I'm a victim of that just like everyone else, we are so used to doing things the way we do things. If you have to add some numbers together on a piece of paper, you should know how to do that. And it's so repetitive and repetitive that I sort of stop thinking about what I'm doing. Stop thinking about how I'm working with numbers and why am I doing things the way I am. That it's important to look at it more objectively with fresh eyes, especially when you're going to be teaching it. Because to little Timmy, adding two numbers together is brand new. He has never seen it before. It seems very foreign sometimes. And we have to have an appreciation for how that experience feels to him. But when I work with numbers, it's been years and I'm so used to it, I stop thinking. The methods we do to add numbers, subtract numbers, multiply, all those things are sort of there to be as efficient as possible, to encourage not to think so that we can just get the answer quickly. But from a teaching point of view, thinking is very important to be able to really understand how this works and to be able to come at it from different angles. So we have sort of 3 steps on the way to looking at our numbers in a better way. We are going to look at 2 number systems from history that I chose because they still have a connection to us today. There are many others that have sort of died out completely and you don't even see any remnant of it anymore. But the 2 I've chosen, you still see them. They still have an influence in our sort of daily lives if you go out and really look. The first one of these are the Roman numbers, the Roman numerals, the Roman number system, call it whatever you want. How did the Romans write their numbers? How did they work with their numbers? How did they represent the quantities that they needed to keep track of? To tax people, to allocate land, and all those things. To calculate dimensions of a building, everything like that. Numbers are, we like to say numbers are everywhere. That's not really true. but they are in more places than we might think, and keeping track of them requires that I accurately represent the quantities that I am working with. Now, some of this will undoubtedly be familiar to you, but maybe there is something that is a little new somewhere, maybe, just to keep things interesting. But I chose Roman numbers because they are familiar. I don't want to take some more foreign feeling number system. Something that's familiar. Yeah, Super Bowl numbers, Roman numbers. Yeah, okay. There's some relevance here. Okay, so we will write the quantities with our decimal system instead of drawing pictures. Some people like to draw pictures instead. But they used familiar letters as the symbols to represent numbers. If they want to represent one little rock, one little dot, whatever you want to call a quantity of 1, that's represented by the letter I. If they want to represent, no, just two little dots, then they would write 2 I's. Now, see it as a font, writing style. I like to connect the I's because it looks cool. There's no other reason. So I like to write my 2 I's with a connected line. Doesn't change what it is. It's 2 I's together. And then if I want to represent 3 things, whatever those things are, then I would have 3 I's together. And writing it like that just looks nice to me. It could, of course, all be separate. And so on. But I'm going to skip some for now. So there's a duplication of the symbol when I want to indicate more. And for the most part, it works like that. So in general, they didn't want to do this forever, of course. I don't want to have too many of these together, right? They're going to blur together, and I can't quite pick out how many I's there are. So I do need some variety in symbols, and here are the symbols that they chose. So their basic symbols that they've decided are for 1 is an I. Could be doubled up, and so on. For a 5, they wanted to introduce a new symbol. That's the letter V. For a 10, quantity of 10, they want a new symbol, an X. For 50, they have the symbol L. Let's go 100 over here. For 100, they have a symbol C, C for century. 500, letter D, and 1,000, letter M, millennium. Now, these symbols, these letters sort of evolved as symbols over time, and it's historically very interesting, but we're not going to go into the detail there. There are YouTube videos for such things, but no one really knows exactly how these letters came to be the symbols. So this is the basic building blocks in terms of representation of our numbers in the Roman number system. So let me just check our book to see if we maybe have some examples. So there is a general rule that we're not going to double up the 5 symbol, the 50 symbol, and the 500 symbol, because 2 5s will be 10, and there is a symbol for that. So as a rule, the 5s, the 50s, and the 500s, those symbols will never be duplicated in a representation because there is a symbol for that. Okay, so that's one rule. And when we can use a bigger symbol, like I'm not going to put 5 I's in a row. I have a symbol for 5, which is V. So by having these symbols, it allowed them to not have too many of the same letter in a row, so that I can look at the representation. For example, I could look at L, X, I, maybe like that. I can look at it, and there won't be too many of the same letter in a row, so I can easily recognize what that is. So how this works in its basic form is essentially each letter brings adds to the quantity. So I have 50 there, I have a 10, and I have a 1 and another 1, I guess, or just 2. So then that would be just all of them added together. 50 plus 10 plus 1 plus 1 gives me the equivalent that this is representing the quantity 62. So in its the first step to understanding the Roman number system is in identifying that we're just listing everything and all the symbols are pieces of the quantity, and I add them all together to see what the representation is. For example, if I want to go the other way, so for right now, it's all just a matter of memorizing the basic symbols. And I can practice that by converting from a Roman number, seeing what the equivalent decimal version is, or from a decimal number like maybe 86, and converting that to my Roman number. So now I have to break up the 80 as 50, and then 30 will be 10, 10, 10. So that'll be an L and 3 X's. That takes care of the 80. And then the 6 will be a 5 and a 1. So a V and an I. So I'm just listing everything, and each letter, each symbol contributes to the quantity. So the 80 is there in this section of letters, and the 6 is represented in the next two. So I'm going down from left to right in terms of the size of the symbol. The size of the symbol is going down from left to right. Okay. So that's the basic idea of how the Romans represented their numbers. Now there's a little bit more, but we're just going to slowly work our way to the more complex situations. This is the first starting point. So I have exercise 5.1. Do I have the space for it? Not really. So we'll go make a new page. So like I said, some of you may know all the letters very well for some reason. Your experience has allowed you to do that. Whereas some of you might need some time to familiarize yourself with all of them. But the first task that I have is to be very comfortable with these. Only 7. Oh, it's not even that many. Only 7 letters that I can use to represent a Roman number. Okay, so we have some practice. Number 1, how is this numbered? A, B, and C. A, B, and C. So A is the first one. Let's see if I can maybe do this. C, they're not that big. C, C, V, I, I, I. C, C, V, I, I, I. All right. So now we want to simply know the values of each of these letters and then add them all together. It's pretty simple. So I have, let's just write it separately. I have 100. I have another 100. I have a 5. I have a 1, 1, and a 1, giving me 208. Now, you don't have to show the detail. You can just write 208. I'm just showing how we're adding up the values of all these numbers. All right. Next one is DCXXV. DCXXV. So let's maybe see if we can do it in one go. I can maybe recognize that, oh, these guys, the D and the C, are hundreds symbols, right? Hundreds, different hundreds symbols. So that's going to be a 500 and another 100, so 600. Maybe I can do it like that. I have options. Then I have under the squiggles or above the squiggles, 2 10 symbols, so that will be a 20. And then I have the 5 to give me 625. So in this sense, the Roman number system is very much a decimal system at its core, because I can look at hundreds and tens and ones separately, always. So it's not really as strange as it might seem to some of you in the beginning. And I can think of hundreds, tens, and ones instead of stretching it out further than that. Maybe that would make things easier. Or my next example, MCCLIII, MCCLIII. I could, if I feel comfortable, just do it all. But I'm in one go, write the answer. But I'm still going to go left to right. That's how I read numbers. And I'm still thinking 1,253. So even though I don't write it out in detail, because I just want the answer, I am still doing that in my head. So there is a risk here in terms of test questions that if you just write the answer and you accidentally make a mistake, I saw 2 I's instead of 3. Now I didn't show any work. And showing work can give me part marks and show that I do understand how to convert. I just missed one of the I's, for example. So it is, I think, better to do it this way, just as a backup. Since I'm doing it in my head anyway, I might as well write them out and show that I understand how this number representation is working in its pieces, hundreds, tens, ones, being very much decimal. But it is ultimately up to you how you want to approach this. All right. Then we want to be able to convert from a decimal number to its corresponding Roman representation. 582, 582. So again, I think 500. That has a symbol D. 80. Well, 80 is going to be 50 and 3 tens. And 2. There's 2 I's. So I very much go one digit at a time. And there's a very close connection between the Roman number system and our decimal numbers. Only in appearance, really, do they look a little strange, with symbols duplicating and so on. where our decimal numbers do not, but underneath how it works, hundreds, tens, and ones, making it far less foreign than we might have thought. 2053, 2000, 2 M's. There are no hundreds, so I skip over the hundred symbols. 50 is an L, 3 is 3 I's. That I like to put together because it looks nice, but it's totally up to you. So I'm simply going left to right and listing the symbols that I need. And as a number system, you want it to be at its core easy to understand, because people have to use it. Yes, at that time, not everyone was educated, but at least for those that needed to learn it, it wasn't a weird and overwhelmingly complex number system. It's not that bad. You just double up some letters when you need to, and you still go left to right, thousands, hundreds, tens, and ones. One more, 168, 168. I see 100. I see 60, which will be 50 and a 10. And I see 8, which will be a 5 and 3 ones. Now, of course, if you're worried about making a mistake, you can certainly write out 100 plus 60 plus 8, and then say that's the 100, that's the 60, that's the 8, and maybe show more work and explain yourself. That's totally fine. But basically, we want to just be able to convert in both directions. Given a Roman number, what is the corresponding decimal number? Given a decimal number, what is the corresponding Roman representation? How do we feel about that at this stage? One second. Sorry, say again. One thing at a time, one thing at a time. I'm building up to that. I can't do everything at once, and then people will feel overwhelmed, perhaps, assuming that you've never seen this before, right? I have to assume that there may be some people that have never thought about Roman numbers. It's just never crossed their path. And then throwing too much information at them at once could be a bad idea. So I'm building up to that. Right now, yes, for many numbers, almost all of them, we can just list all the letters, and that would be this additive property of just adding them all together to represent the quantity involved. However, they found that, let's do it underneath here. They found that it's confusing to have too many of the same letter. Sorry, I'm writing and saying something else. They found it confusing to represent 4 with 4 eyes. That was sort of their threshold. Like 3, okay, we can easily just look at it and know there were 3 eyes, or 3 of the same symbol. Or 40, 4 X's. They felt, no, 4 in a row, that doesn't seem... They start to blur together. So they were happy with 3 in a row, but not 4. They found this confusing. So they said, no, we're going to run into trouble, because we need to effectively communicate. If we're going to write our quantities, we need someone else to quickly read them and understand them and not have any confusion. And when we see 4 in a row, some people seem to be getting confused. Let's try and avoid that. So instead, they made the rule, like, I'll never have 4 of the same symbol in a row. But that means I have to add a little bit to my system here. For 4, I'm going to see this as 5 minus 1, 1 less than 5. And I'm going to now introduce a technically new symbol by recycling old symbols. And I'm going to put a small I in front of the larger v, breaking my rule of going downhill. Where did I do that? Here. Going down from left to right, smaller and smaller and smaller symbols. This is now the exception. So very much these two are glued together. They form a new symbol. I'll call it a subtractive pair. They're not separate from each other. They are glued together. And whenever I see an I and a V, an I and then a V, that is one symbol to represent 4 in this subtractive way. And 40, which is 50 minus 10, will be represented by its own subtractive pair, 10 before 50. That is a new symbol. And what makes it confusing, perhaps, is that this new symbol uses existing letters. They could have made a brand new letter for this, but they chose to recycle the existing letters with the understanding that we now have this subtractive property. Okay. And then, of course, we can do 400 in the same way as 500 minus 100, leading me to a new subtractive pair, 100 less than 500. All right. Now, they also have the issue that 9, for example, we don't want to say it's 5 and then 4 ones, because then we have 4 of the same letter again. So the 9s have a similar issue, where they have their own subtractive pair. 9 will be 10 minus 1, leading me to a subtractive pair ix. But again, it is its own symbol. It just happens to consist of existing letters. It is now a new symbol in a way. 90 will be 100 minus 10. I don't know. So that will be xc, new pair, new subtractive pair. And 900 will be 1,000 minus 100, leading me to cm. So we have these new symbols, really, that whenever the 4s or the 9s come up, then I need to use these symbols instead. All right. Think about that. Think if you have any questions. I will be right back. Okay, we're back. Sorry about that. Lots of time you had to think. See if you like this new system with these subtractive pairs. All we have to do is practice. And maybe you have already started. I should have put that on the screen. Well, let's make a new page here and see how we feel. And it's really, I don't want to go fast. Don't take these breaks on purpose sometimes. Because I want to make sure those that need the time take the time to memorize and understand the basics. Many times I see people trying to do the later exercises and then get confused. And it turns out they just didn't memorize the symbols yet. You need to, again, build this up correctly. Okay, 5.2, number 1, A. 5.2, number 1, A. CCIV. CCIV. First of all, I have to read the question. It says, determine if the following number is a valid representation. Sometimes, if it asks this kind of question, it's giving you something, and it might not be a valid Roman number following the rules that we've established. You have to decide, is this allowed? And if so, what is the corresponding decimal number? Yes, it is allowed because everything is going down, CCIV I have here, except the subtractive pair. So what I like to do is put a box around any subtractive pair that you see. And apart from those, everything has to go down left to right in value, in size. So here I have 204. 200s and the symbol for 4. B, XCV. XCV. First of all, is it valid? Well, what would help me is to identify the subtractive pair that I see. That would be 90 and 5. So another rule that I'm not sure if it's in the book. Nope, not there. Not sure where it is explicitly in the book. Is very important to identify if a number is valid or not. It's not as crucial when I try and make the Roman number and write it down. I don't really fall into this trap, but it is an important one to be aware of. That if I think decimal, let's say here, thinking decimal, meaning I'm thinking in hundreds, tens, ones, that. Let's say here, thousands. I should write this way maybe. Hundreds, tens, ones, and so on. When I represent the hundreds, for example, I don't want to represent some of the hundreds and then some other hundreds later. And then some tens here, maybe I'll have an X, and then maybe another X, and then an L to represent 10, and then my 40. Maybe all the tens are there, but I can't separate them like that. When I represent the tens, it has to be the correct symbol all in one go. There could be a couple of them, but I can't separate some tens from other tens. Okay. Now that's hard to write down here. Let's say here, all in one go. Each place I have to represent in one go and not split up the place into some and then some more. Okay. Just like here, all the tens are handled by the subtractive pair. There are no other tens symbols. Then all the ones. So let's keep that in mind as we go forward. It's a little bit hard to explain without a specific example. XCXXV. XCXXV. First of all, I have to decide, is that a valid representation according to the rules of the Roman number system? Well, to help me, I identify a subtractive pair, the subtractive pair for 90. And of course, I'm expecting that you know these right away as we do these examples. They might require some review and practice, absolutely. Which is why this is as far as we're going to go today. So I see that there are some tens being handled by the subtractive pair symbol, and then some more tens. And that's exactly the issue here on the right. I can't do some tens and then some other tens later on. That's not valid. It's not valid. Because what this person was trying to represent here was 90, and then a 20, and then a 5, leading me to, what, 115? But 115 has a different way of being represented. 100, 10, 5. So this rule came about to avoid the possibility of having the same quantity being represented in multiple different ways. For a number system to really be effective and for the civilization to be built on that number system to a large degree, I have to have one way to represent the quantity. Sure, a different quantity, different representation. But if I have 115 chickens on my farm, there's only one way to represent that amount. And as soon as I have multiple ways to represent the same quantity, that's when confusion begins. And that's where regions of the country can slowly drift away from each other in terms of effective communication, because information doesn't transfer as quickly as it does these days. Everything happens very slowly. And if there's any sort of confusion, that confusion causes people to drift apart, and in a little while they can't communicate anymore. So it's very important to establish the rules of your number system in such a way that it's not overly complicated and that any quantity has only one representation. And I can avoid that by not doubling up the fives, not repeating the same symbol more than 3 times, and also this decimal thinking that each of these places have to be handled in one go and not some and then some others later. Okay, a more subtle rule, but it is important. Okay, one more, I think. D. Ooh, it's a long one. CMCC. I'll write these in pieces. CC. XLIV. XLIV. Okay. First of all, is that a valid representation? Well, I identify some subtractive pairs. There's one. There's one. Okay, because the subtractive pair symbol is one symbol. Yes, it consists of a couple of letters, but those letters can never be separated from each other. So I put a box around it to help me. And now I see, okay, well, this is a 900. So it's a 100 symbol. But then some other hundreds are handled here. That's not going to work. Oh, there's an XL here as a subtractive pair as well. But that's okay because that is a 40. That's a tens number. And the 4 is a ones symbol. But the hundreds, they can't be handled in multiple pieces. It's not a valid representation. What is it trying to do? It's trying to represent 1144. But that has its own representation. 1144. There can be only one way to represent a quantity, and that's it. The rules are there to ensure that. Okay. So we want to be able to convert from Roman numbers, but also to Roman numbers. And that is definitely the easier direction, I think. So we have A, B, and C. A, B, C. First one is 694. 694. Now you can show more work here if you want, but we will always think of it in a decimal way, separating the hundreds, the 90s, and the 4s, and then handling them separately, but all in one go. 600, 500, and 100. 90, that's a subtractive pair, which will be 10 less than 100. 4, subtractive pair, 1 less than 4. Now, when I string all the letters together without spaces or grouping or anything, then it looks much worse than it is. But I'm thinking hundreds, tens, ones when I construct this representation. 2991, 2991. Again, you can write it if you want. to show your understanding of what you're doing. Absolutely. Whether I write it, I'm still thinking in this way. 2000. 900 is a special pair. 90 is a special pair. And 1. So you see here, if you look, it looks as if, oh, but he said from left to right, it has to be decreasing symbols, and now an M appears before, after a C, but this is very much its own symbol, just like this is its own symbol. And then everything's going down left to right. Once I've sort of made that a single symbol, which it is. Last one, 89. 89. 89. What do we do here? Again, you'll avoid a lot of confusion or possible mistakes by thinking decimal. Thinking decimal. 80 and 9. What's the representation for 80? 50 and 3 x's, and 3 of them are okay. Then 9 has a special pair. It's when people don't look at this in the appropriate way and forget the core decimal system really underneath the letters. That's when they start mixing things up and get all loose with the rules. But if I think hundreds, tens, ones, and handle them one at a time, but when I do, it's all in one go, then everything should be pretty straightforward, to be honest. All right. Any thoughts or questions about this? Again, practice as you need to. Memorize these symbols. There's no way around it. Where is it now? You need the basic symbols. You need the subtractive pairs, and then the basic rules for how they're put together. If you need to take more time to memorize this, do it. We need it. We can't move on without it. But maybe some of these are familiar, and you don't have to actually learn that many new things. All right, we will continue. Today's Wednesday, right? We'll continue this discussion tomorrow, and I'll also check the schedule to see if we're on track. But if there's any updates, the schedule will always be kept up to date. All right, until later then.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.